Hello everyone, welcome to modding lesson number 5. We're going to talk about entity animations, spawning, and then a little bit extra today. So just to introduce myself, I'm Kat. I'm a 4th year cybersecurity major and I've been modding for 8 years. So let's get into it. The first thing is we're going to review entity data, and that's because I didn't write these slides until after last week. So we're just going to briefly review the things that I did during the demo, but in slide form. So serialized NBT data, when you want to write data that persists across sessions when you exit the world and rejoin on an entity, you can override the read additional data and add additional data methods, and then those provide a compound tag which you can use put to write data to and get to read data from. And there's different methods for different data types. So in read additional data, you'd be using get methods exclusively, and in add additional data, you would be using put methods exclusively. And the data really only exists, it's only written on the logical server, so the client doesn't persist data using NBT at all. So this is only a thing on the logical server. And then you have networked entity data, which is the entity data accessor system, which lets you sync data over the network to the client from the server. So this is just a slide review. So you have the define ID method there, which you can specify a key, which is basically a channel for data to pass through of a specific type with a specific name. And in that you define a class that it's tied to. It's very important that that class is actually your entity and that it's in the correct location. Otherwise, it will break things weirdly and cause weird packet stuff on the client. And then to add those keys to the entity, you would override define sync data and use the builder define method. And then you can read and write data over that key using the entity data object on your entity. So now into the actual content for this week, we have entity animation. This is a fun one, guys. So much cool stuff. So there are 3 general ways in which you animate entities in Minecraft. So you have math animations, which are what Minecraft has historically used. They use things like Sine and Lerp, algebra, to transform the position, scale, and rotation of different model parts over time. So it's mostly used for simple movement that's isolated to one or a few parts at the same time. And then you have keyframing. So keyframing is at least vanilla keyframing is a new sort of thing. Modders have been doing it for a while, but vanilla has their own implementation now. So the concept behind keyframing is you set specific points to interpolate between with different algorithms, and those have set times that each frame is, and then in the time between it sort of does math to go in between them in a smooth fashion. And it allows for more complex stuff that coordinates between different parts in a more predictable system. So Blockbench can actually export these. And then also GeckoLib, which I'm not going to be talking about very much today, but is actually very prevalent. A lot of modders use GeckoLib. It's a third-party library that provides complex animation logic, state management, and rendering systems. So it has its own model format called geomodels that are JSON based rather than just code based like Minecraft vanilla ones, which is nice. And it integrates with Blockbench as well, so you can download a plugin for it. And it also supports blocks, items, and armor, which is a huge plus, and it uses the same format. It can also animate those, so it's really cool. Do recommend. So now we're going to talk about math animations. So I'm going to do an example here. So consider the legs of a player. They alternate back and forth, rotating, right? And the alternation is smooth, and it changes depending on your walking speed. So if you're walking very slowly, your legs will only go out a little bit. If you're walking very quickly or sprinting, your legs will go out to the very end, okay? And then if you stop and then start walking again, your legs immediately step from the default position. They don't just teleport back all the way out. So if you also consider a sine wave, right? This is the function y equals sine of x. So if you imagine that the y-axis is the rotation of the player's leg, and that the positive y is forward and the negative y is backward, and then you know some trigonometry, you can mess with this sine wave in a lot of ways, amplitude and frequency. So here's an example of what you can do with a sine wave. The amplitude varies, but depending on the outside factor, so you can see that graph there, where it's getting much taller and then deeper. And then the frequency varies by multiplying the inside, so that makes it oscillate more often, which alters time as a factor, basically. So vanilla uses this to accomplish a simulation of legs moving. So if you transform the sine wave, you get what looks like a leg moving. So there's two variables that setup_anim gives you, which is the default animation method on entities. It gives you limbSwing, which represents the time factor. So it's basically the as you walk, this increases by a set speed every single tick or frame tick. And then when you stop walking, it resets, so that you start off from the same point, basically. And then you have limbSwing amount, which is the amplitude. So that's basically your current movement speed. And then here you can see the actual code used for quadrupeds, which are four-legged animals in Minecraft. So it's using cosine, which is the same thing as I just showed, but shifted 90 degrees. So one important thing about Minecraft animations is that it represents rotations in radians, not degrees, which is the more sensible thing to do in this case. So 2 pi radians is 360 degrees, if you didn't know that. So if we look at this example, you can see it's multiplying by 0.6662 inside the cosine function, which is basically just cutting the oscillation of legs movement by 2/3 for quadrupeds. And then on the outside, it multiplies by 1.4, which just increases the distance that the legs can rotate forward or backwards. And then you can also see that the left hind leg and the right front leg they have math.pi being added on the inside. So what that's doing is basically shifting the time factor by a fixed amount, and that makes it appear as though the legs are alternating, because the front, so the different legs will go back and forth at the same time in different directions. So if you want to look a little bit about how the limbSwing and limbSwing amount variables are sourced, you can see that in setup_anim, it's being passed this from the renderer, limbSwing and limbSwing amount. limbSwing comes from the walkAnimation.position method, which you can see right here. So it's returning the position here, and the position is determined by the last position plus the current speed. And then you can also see that the limbSwing amount is determined by the speed here. So this speed, it uses partialTicks and then interpolates between the old one and the current one. And so the speed is basically the player's actual walking speed. And then you have partialTicks, which I'm going to explain in a second. So you can see that every single tick, the position shifts by speed, which is the current player's walking speed. So as you walk, the time factor increases, essentially. And then when you stop walking, time factor resets, the time being position in this case. So linear interpolation, I mentioned this a few times, but linear interpolation is an equation that smoothly moves between two numbers in a linear fashion, hence the name. So given a progress from 0 to 1, it will make a number in between 2 points that is in a linear fashion. So at 0.25, the result of a Lerp function is 25% of the difference between the two ends, or it at a point that's 25% of the difference. So if you consider a Lerp from 5 to 2, at 0, it's 5, and at 1, it's 2. But in between that, it can be represented using the equation y equals 5 plus 2 minus 5 times t, with 2 minus 5 in parentheses, as you can see. So that's basically the difference. I mean, it's an equation. So you look at that graph there on the right, you can see the green section is the linear interpolation. So as time proceeds from 0 to 1, it approaches it in a line. So it's just linear algebra, or not linear algebra, but linear equations. but it's useful to us for this reason. So partialTicks, that was a variable that exists inside of setup anim. It's very useful. It's all over the Minecraft rendering code. So what partialTicks is, think about it, the game processes everything at a fixed speed, on the server at least. So 20 ticks per second. Every entity updates how fast it's walking. Everything updates, right? But the client can do much faster than 20 frames per second, right? It can go up to the hundreds. So if the AI only changes every 20 times per second, but the game's updating like 60 times per second, then it's only updating every 3 frames, so it's going to look really choppy on high frame rates. And like 20 FPS is not very fast. You can notice 20 FPS. So to get around this, what it does is it runs everything 1 tick behind animation-wise, and then uses the difference between the current tick and the tick before that, and then calculates a fraction between the two and performs a linear interpolation between them. So I'll elaborate on that. So if we know that the last tick's rotation was 2 degrees, the current is 4 degrees, this is an example, and the frame rate is 60 FPS and the tick rate is 20 TPS, right? We can calculate the number of frames between the between ticks, like the number of FPS, sorry, not FPS, the number of frames required to equal 1 tick. So in this case, 60 FPS divided by 20 TPS is 3 frames per tick, right? And then we can calculate the progress based on the number of frames that have been rendered between the last tick and the next one. So if we're at frame 4, then 1 tick occurred at frame 0, 1 tick occurred at frame 3, and now we're on frame 4. So there have been 1 of the 3 ticks between frames. So we can say that our partial tick is 0.3333 repeating, so 1/3. That's our partial tick, because the partial tick is a value that ranges from 0 to 1, where 0 is frame just happened and 1 is the next frame happening. So every single frame, if we take that 2 degree value from the last tick and the 4 degree value from the current tick, and then we linearly interpolate between those 2 degree values and use partialTicks as the progress, so a range from 0 to 1, then we will get a smooth looking, linearly at least, a linearly smooth appearing animation between 2 and 4. So at 0.5 partialTick, then you would get 3 as your degree value. So it will smoothly animate between those two at the highest rate it possibly can. So that's how animations are generally accomplished. And that's what the Minecraft code was doing when it was making those limbSwing amounts increase by a lerped partialTick. You can see that right here. It's doing speed is a lerp of partialTick from the old speed to the new speed, which is exactly what I just described. So one more special consideration before we write our own math animation is pose leaks. So like I said last week, every single entity model, or every single entity of the same type shares the same entity model because they share the same renderer, right? There's only one instance of the entity model for each entity type. So if you were to adjust a model part's position or rotation, or do an animation on it, it would apply to every single entity, right? So each entity basically takes turns using the model to render itself. And if you were to, say, move the leg to a certain distance and then leave it like that, and then the next entity that used it decided, oh, I'm not going to touch the leg, it's not important to me, then the leg would still be in the same position as it was the last thing that used it. It doesn't reset itself. So it's important to, every single time that you call an animation, like in setup anim, you should make sure that either you're setting the animation every single frame, as in every single object is set to something every frame specifically for that entity, or you're just setting it to the default when you're not using it. Otherwise, so basically you shouldn't conditionally manipulate the pose of the model at all. You need to set it to a default or set it to something. Otherwise, it can potentially leak between entities. So now we can make our own little entity animation using math. So if you don't have any entity code, you can always copy my project, which is on GitHub. But so in the lizard model, we have the setup anim method, which lets us write all of our animations. So one thing that you'll see that I made a mistake last week is I didn't really understand how Blockbench exported stuff. So Blockbench calls model parts groups, or also bones, and then it calls boxes, which are these add box, cubes. So in order to actually animate things, you need to have them as a bone rather than a cube. So what I'm used to doing is actually every single cube corresponds to exactly one bone, but that's not like always standard. So I'm gonna go in Blockbench and I'm gonna open my my lizard and I'm gonna fix it so that we can use it for animations. Which I think I moved said lizard somewhere. Here he is. All right, so you'll see everything here is just a cube. And the other issue I was having is I didn't know how to parent things. So to parent things, you create a group. So we're gonna call this one body, and then we're gonna put the body cube in there. And then inside that, I'll create another group. And this will be front right leg. And then I can put the cube inside. So now the front right leg is animatable because it has this group. So I like to do it this way where you have one cube to each group. Otherwise it gets a little bit confusing because you can't animate every single cube if you don't have a group for it. So the other advantage here is now if I like move this, right, it will move the children as long as I change the space to the right one. It's like if I rotate it, right?
You're selecting the cube inside of the group.
Ah. Yeah, so if I rotate the group, now you can see everything that's attached to it is rotating as well. So that's very nice to have now that it's like parented correctly. But I'm just gonna finish making groups for all these. Front leg, front leg. And then inside the head, I will put the snout so that the snout will rotate with the head. Ta-da! So now if I were to rotate the head, look at that. Except the head has the wrong pivot point, so we can actually move it using this. Oh. So that looks correct to me. Now if I rotate the head, it has the right pivot. So the next thing is making sure that all the pivot points of these are correct, which I believe they should be because I made sure the cubes had the right ones. But yeah, so that looks correct to me. And I would also like the tail to have a good pivot, which it looks like it does. Oh, that's not right. Oh, because I was rotating the wrong part. I don't know why the pivot point is all the way up there, but so I have to make sure to be careful to, yeah, so that's not in the right place. So now if I rotate this, that's much better. I kept selecting the boxes instead of the groups, which I need to not do. Okay. Wait, which one did I just... Okay. Ah, there we go. So now all the pivot points match correctly where I want them to be. Awesome. So now I can save our lizard here, and then I will export. And I'm just going to do it to the desktop real quick because I want to just grab the new layer here. So you can see that it gave me more parts now. And it renamed it from root to body. Ooh. Do not need all of this horizontal space being taken up. So now I have all the parts that I can use, and I need this to be correct. Lizard model. So now all the parts are available, and I can do stuff like this. This dot back right leg, ta-da, and then I can set its pose. So what I was saying I wanted to do was I wanted to rotate the lizard legs like I showed earlier, where it's like going out. So that is the rotation on the y-axis, I believe. Although it might be the z-axis, we're just going to try it. So if we just use the same leg movement code, where we're doing math.cosine, and then look, it's recommended the correct code already, so that's nice. So that would be for the back right leg. One other thing I want to make sure to be careful of is that this will set the actual rotation like it's where it zeroes to 0. So I have to make sure that the y rotation on this back left leg is actually 0, like it centers at 0. So if we look, it doesn't look like there's any rotation on it, so should be okay. So if that's the back right leg, then we can do the back left leg, and then we're going to add float math.pi to offset it. Then we're going to copy this again for the front one. So this should be the front left leg, should have the normal one, and then the front right leg should have the flipped one. That way the legs are alternating in the way you would expect. So this is probably going to be a little too much like movement wise. So I'm going to actually remove the 1.4 here and see how that looks. And then I also want it overall to move much slower. So I'm going to do 0.333 because that will reduce the amount of oscillations that it can do per second. And I think that would look good. So if we take a look at it, let's see. So, and also you'll notice that even though every entity might not like have the same leg movement, we're setting the leg movement every frame, so nothing is going to leak its pose between entities. So now if we go look for our lizards, we'll see that their legs may be moving when they're running, which they are, they're just very fast, so you can't really tell. But you may have, if you nudge one, right, their legs start going out. It's awesome. Although they don't look the way I would expect, but that's fine because it's really just for demonstration purposes. If you hit it, you can see them. You can see their legs, their little legs go out. They're so cute.
They're very fast.
Yes, they are so fast. But the faster they're moving, you can see their legs jump out. I actually think that's really funny. Yeah, even though it's not like moving back and forth, because they're moving so quickly that their like limbs are swinging like faster than you can even see them possibly move. It's very funny. It's very good. So, I'm happy with that. Now the next step, since we've mastered our math animations there, not really, but I mean, actually, I do want to show something else. So I want to make a little math animation that uses our explosion ticks here, right? So, like, say we wanted the body to gradually, say we wanted the tail to gradually grow as it explodes, right? So we already have the whole entity grow, right? But what if we wanted the tail to get like relatively larger? We could animate the tail increasing. So the problem is, well, here's actually scale on cubes isn't like, it doesn't do fractional scaling. So there's no, I want to show you how to use linear interpolation with partialTicks. How about if we make the tail rotate as it gets ready to explode, right? Around its like z-axis, so it would be like rolling in circles basically. So if we were to just use the ticks to explode, right, that value only updates every single tick. So then if at 20 FPS, or it would only basically be able to render at 20 FPS. So what we're going to do is we're going to make a lerp. So what we can do is this dot tail, right? And then we can do Z rotation. Actually, is Z scale smooth? Oh, it is. Okay, so if we want the tail to get longer as it explodes, we can increase the Z scale. So we can do ticks dot to explode is equal to -1. Then we're going to make sure it's the default, which is 1, I believe. Let's take a look. Yes, that's what that is. Otherwise, we can increase it from a certain number. So if we do a linear interpolation, and then, okay, wait, this actually presents a problem. So if we wanted the scale to increase in a linear fashion between frames, we can use float target tail length will be a number which is decided by the fraction of ticks to explode. So ticks to explode has a maximum of 200. So if we do ticks 200 minus ticks to explode, so that's how many ticks it has been ready to explode for out of 200. That will give us a reverse count, basically. So at 0, it would be just started exploding, and 1, it's fully exploded. So that's what this number is. We could also write this as 1 minus ticks to explode divided by 200, which I think I'm going to do because it just reads better that way. So now we have a number that represents the progress in explosion, and let's say we want the tail to reach a maximum length of 5 times larger than its normal value, right? The problem is that ticks to explode is not going to update smoothly. It's going to jump between every 3 frames, right? If we're at 60 FPS. So the best way to do this, well, this isn't actually the best way because I would write this a different way. We could actually directly lerp between them, but I'm going to do this for demonstration purposes, where we have it starts at so we know the target tail length for this frame, and we also know we can save the previous target tail length. So that's what we're actually going to do, is we're going to go to the entity, and we're going to store this, because remember, if I were to just store this in the model, it would leak. It would not be unique to this entity, and different entities can have different ticks to explode values. So I'm going to do, we're going to have a public float client tail length equals 0. And I'm also going to make sure here that we add 1 to the scale, because this target tail length is from 0 to 5. We want to make sure that it starts at 1, otherwise it's going to shrink before it grows. So now on the entity, we can have the client tail length. I'm going to name it last client tail length, because that's what it was, the last frame, not the current frame. And so this field is really only being used on the client, but exists on the entity. So that's where we can like kind of see some of the things where sidedness like shows itself, in that field is really only used on the client. And so if you were to go on the server and try to access that field, that value isn't going to be the same. It's going to be 0 no matter what, while on the client it may have a different value. So threading, each thread has its own memory. So the version of the lizard entity on the client is not the same as the one on the server, even if they're running on the same computer. Fun things to consider. So now if we interpolate between the last one and the target one, and then we use partialTicks as our value, which they haven't given us, but we can do Minecraft.get instance dot partial. No. I forgot what they named it. What did you do to my partialTicks? Have prepare mob model. What is this? I want partialTicks, guys. There it is, partialTick time. That's how you get it statically. Oh my god. For some reason it doesn't give you the partialTick time in the setup ANA method, but now we can linear interpolate over partialTicks because we have them. So basically from 0 to 1, we're going from the last length to the target length, and then now we're going to make sure that we set the last length to the current one, so that the next time that this updates, it will have the right value. Although we'll need to do that in, it'll have to be inside the entity, because otherwise this will update every single frame. So it won't be like smooth between ticks. So we'd have to go, we could actually calculate this using last ticks. We can make a field called last ticks to explode, and then just calculate that every frame instead. So if we do last ticks to explode client, and then go into our lizard, and do equals ticks to explode. So now we have the value from the last frame, right? So if the last value is equal to, we need to set a default value, otherwise it's going to look weird, is equal to -1, then we're just going to make sure that it's not, that it uses the current value instead. So starting from scratch. Otherwise, we can use the default one. So then we can have the target tail length, and then we can have the last target tail length, which is going to be the same as the normal one, except now we will use the last ticks to explode. So now we're only using values that are updated by the frame. This will get updated when the so instead of updating it every single frame, we will update it in the entity, which will update every client tick. And that happens right here. So as long as we do it before we subtract, that's what I want to do. Before we reduce it, then we set the last ticks to explode. Cool. So that should theoretically make an animation that uses linear interpolation. And then I want to show a version that doesn't have it so you can see the contrast there. So first I'm going to show you the version with linear interpolation that I just wrote. Okay, so if I feed one of these guys a fermented spider eye, which is their explosion food, they will start exploding, but you'll see that their tails are extending now, right? And it looks fairly smooth, if I can get them to stand still. It looks fairly smooth between frames. Now in the recording it might look a little choppier, but it's actually increasing at like a fairly normal interval considering. So you'll notice that between like the 3-frame intervals, like you barely see any chopping. But if I were to go into this and then not do linear interpolation, so if I were to just do that, right? Set it straight up to the value that I calculate every frame, you'll see the difference. You can sort of, actually really can't tell the difference that well, but that's because the ticks to explode updates every frame. If I were to make it update instead like every tick, if I were to make it update like only on every second tick, so if I go to the entity and then I make this so if I only de-incremented ticks to explode every third tick, there's a variable on entities called tick count, which is the number of ticks in which they have been loaded into the world. So if tick count mod 10 is equal to 0, then it will update the ticks to explode. So now we should see that the rate at which they explode is much slower, and we'll be able to see more distinct segments in their tails updating. Yeah, you can see the segments in which their tails increase. But even if I increase the rate like that, if I were to turn on the linear interpolation, it's going to be smoother between frames. So stop that. I don't know what it is doing. Now, this isn't as applicable because the ticks to explode is updating every 5 ticks, but partialTicks only covers a range from 0 to 1. So now the tail is probably going to jump back and it's going to like get stuck for a certain number of frames, but then when it transitions, it will then interpolate between the frame. So it's going to like smooth and then stay still and then smooth and then stay still for like 4 ticks because of the rate at which it updates is no longer every tick. So the partialTicks value isn't really accurate anymore to how often it's updating. So you'll see that's basically doing exactly what I just described. So notice the tail is growing and then stopping and then growing and then stopping, right? But see, when it's growing, it's very smooth. Like when it does grow, it actually jumps in a like what looks like a frame like smooth manner. So that's the difference. That's the thing that you can't see is like at a sub tick level, it's actually much smoother with that. So if I were to update that lerp to instead lerp over a partialTicks for like 5 ticks instead of, because that's how often it was updating, or 10 ticks, every 10 ticks, right? Then you would see it smoothly animating between those two every frame. So that's what that is. Hooray. That was very drawn out, but a good way to show what linear interpolation does. So now back to the whole lesson here. So keyframing. Keyframing is a more advanced way to decide, well, okay, keyframing is a more defined way to animate things. You give things specific points to move between, and then it moves between them over time. So you can do multiple different directions, different rotations in a sequence, right? Keyframing is how most animation is actually done. You have different frames and you move between those frames. So Minecraft has their own implementation of keyframing now. They didn't used to have that, so you used to have to like write your own basically. But now they have their own version of keyframing. It's used by things like Wardens for more complex looking animations. They make things look more alive when done right. So like Java models, like entity models in Minecraft, they're written in Java. The whole animations, they're not like data, they're not JSON files, they're just Java code. So you have the keyframe animations.animate method, which is what actually does the animation. But in order to actually implement an animation on an entity model, you have to make sure it's a subtype of hierarchical model, which is basically just a model that uses bones or groups in the same way that we just did with the lizard. You extend that and then you specify like a root model, and it adds a bunch of methods like the animate method. So you call it with an animation state and an animation definition. So the state just defines like how the animation runs, like what duration it has, or what current position in its entire duration it's at, if it's running or not. And then the definition is the actual animation that it's going to perform. So each animation definition has a length as well as animation channels. A channel is just a part and either position, rotation, or scale. So a channel is one specific thing to animate. And then each channel has different keyframes, which have a time offset, and then their actual like value, so position, rotation, or scale for that channel. And then each keyframe has an interpolation mode, and that changes like how they iterate or how they smooth the keyframes. In between the keyframes, it can be like a straight line, it could be exponential, it could be like a curve, ease in and ease out, that sort of thing. So that each keyframe has its own interpolation method you can define. So it's keyframes are really good for like fixed duration animations that are associated with a state and have a little bit more complexity to them. So here's what a keyframe looks like. This is the Warden's attack animation. So you'll see on the very left there, that's how the entity actually triggers animation to occur on the client. If it receives like a start attacking event, which is an entity event with an ID of 4, it roars, or it stops roaring, and then plays the attack animation. which gives it a duration, right? It starts it with a duration, and then inside of the entity, the setup anim method calls animate with the current attack animation state. So if that attack animation state has been started, the engine knows to actually start the animation. And you're also passing the Warden attack animation definition. And you can see that animation definition right there. That's what one looks like. So they have which bone is affected, and then the channels for that bone. So in this case, we're editing the rotation, and then at 0 seconds, it's going to be at 0, 0, 0. But at 0.04 seconds, it's going to be at -22, 0, 0. And then you can see the interpolation method is cat mole rom. Not exactly sure what that stands for, but I'm sure it's useful. That's probably, I think that's the standard one. But nobody actually wants to write animations with Java code. I don't think anybody does want to pick out numbers and try to imagine what that would look like. So you use Blockbench. They have their own keyframe animation editor, and it's awesome. So only groups and bones can be animated the same way. Like you can't, I just showed, you can only do it with the bones rather than the cubes. And it's way easier than trying to do it by hand. So you can see there, I exported an animation, and what I got was that thing on the right there, this little animation definition. So now we're going to make a keyframe animation, and we're going to apply it. And this is a learning experience for me too, because I've never done this. So we open Blockbench and get our little lizard guy. Look at him, he's so cute. You'll notice there's a tab right here called Animate. And we can actually create an animation. So we're gonna call this one nod. So we're gonna make it nod. And I think it will loop. And let's see. I think everything there looks good. So nodding animation, I think it's gonna last 1 second. And so all the nodding animation is gonna do is we're gonna take the head, we're gonna add a channel for the rotation. So at 0, it's gonna be at 0. At 0.5, I'm gonna add another keyframe like that. And I'm going to change the rotation for that keyframe. I'm going to change the pitch, right, of the head to -35 degrees, and then at 0, and then back at 1 on the timeline here. I'm going to add another keyframe that puts it back to 0. So now if I play this, it looks good, but I actually want a little bit more to this, so I think I'm going to put this at 0.6 or so, 6, 7, right? And then at 0.33, I'm going to add another frame, and that's going to go to +35 instead of -35. So now, or maybe not all the way down there. Maybe like 10. Okay, so now if I play this, so it's a little inconsistent because the animation is different there. I think if we do something like this, it'll look better. Yes, that looks great. It's nodding. So you can actually do it on multiple parts at the same time, which is what's really cool about this. So if I were to add a rotation to the front right leg at that frame, right? And then I play this now, you'll notice it's looping. So it's very, very powerful. So now we can export our new animation. And I'm just gonna export it over the old one because I only need the code for it. I don't need this actual class, right? It gives you this small little animation definition. So I'm just gonna put this in the lizard model because I don't really need it anywhere else. Okay, so now we've got our animation. I'm gonna name it all caps nodding animation. So now we need a animation state, which I actually don't know how to use these, so I'm gonna look at the Warden real quick. It looks like it's just something like that. So if I go in the lizard, make one called nodding animation state. And then if we want to trigger the nod, how about it's if I give it a different item. So like if item stack dot get item is items dot. How about if I give it a cannon? Right? Then I will do, and then we also want to make sure that we're on the client here. If that, then this dot nodding animation state dot start if stopped. And then I'm going to make it run for 40 ticks, so 2 seconds. Not, I believe. So the tick count, well, I want to figure out what the tick count does. Accumulated time. So if the accumulated time so I'm not sure what actually stops these, but I'm going to say that's fine. So if we look at the Warden, let's see what else it does with this. It starts it. That's it. But I think that I actually do need to make sure that this stops. I don't know. That's fine. I'm not worried about it. This is just an example. So if we go on our lizard model, the way to do it is this dot animate, right? But we are not. It doesn't exist because this needs to be a hierarchical model, not a entity model. And that comes with a new method we have to implement, which is root. So root is this, its body. We just need to tell it which part is rendered. And then I believe that also means that we can delete our render to buffer method. Well, not delete it. So the root is used right here. They call it for you, so you don't need a render to buffer override. But since we're editing the color here, we actually do. And we're going to leave it how it is then. But we can make it more like, have some parity by doing that. So now we're a hierarchical model. We can use this dot animate. And then we're going to give it the entity nodding animation state. And give it the nodding animation. And our age and ticks. So age and ticks is just how many ticks that it has existed for. It's the tick count variable I was talking about, but on the client. So that's how the animation knows like how time is proceeding. Otherwise it doesn't know anything about time at all. So now that that will make our entity react to the nodding animation state. The one thing with these hierarchical like keyframe animations is if you try to animate something that you're setting here, the animation would overwrite these. So they have this animate walk, right? So you have to actually keyframe your walking animations as well. These are using the limbSwing stuff. So see how it's like, it's generating the limbSwing stuff and then using an animation definition and like caching between frames. So this is basically a keyframe way of implementing walking animations. But because none of our animations actually animate any of these, it's fine. Like, it won't affect anything. So you have to be careful with mixing the two methods there. So one way you could like alternate between the two is like, I could conditionally call this.animate and then it wouldn't like set the pose of any of these if I were trying to animate them, as long as the animation was active. Important thing though is just avoiding that pose leaking thing I was talking about earlier. Look at him go. He's beautiful. Anyway, if we feed one of these a cannon, they should start nodding. That doesn't look how it's supposed to, but it does in fact work. I don't know why the rotation is doing that. Can we not do that? Okay. So, I'm a little confused what just happened. Oh, they're state leaking. Are they? Hold on. What is going on? Okay, so what I'm going to do is I'm actually going to turn this into play once animation instead, and then make it 2 seconds long, and then copy the whole like spiel here and shift it all down. So now it'll do it twice exactly, right? And if I export this, then we have our definition here. And ta-da! The one thing I'm confused by is why these are not in radians. See, it's converting them to radians. They're just animating way too much. I think me changing that number inside lizard entity to 0, yeah. So I'm going to try it like this and see what happens now. Since it doesn't loop. Oh, okay. So the tick, it actually wants a tick count. That's what it wants. That's why it was not working. So you're supposed to call start with the current entity's tick count for some reason. Oh, it tells it when the animation started so that the animation like keyframing engine knows what their relative like time to start and stop the animation are. That makes a lot of sense. Basically committing it to memory so it knows what the current time was when it began. So it can calculate the end. Yes, looks good. Alrighty. Who wants it? And yes, I'm giving it away. I don't know why their heads are doing that. I'm gonna be so for real. And also, it's not resetting. And I think it's leaking. Because if I look at one of these guys, their heads are all down now, even though I didn't give that guy any. So that's a nice consideration, is that it doesn't seem to reset to the default when you're not using it. Why? Okay, but it also should reset, because this one says so. So I'm just gonna say that Minecraft just doesn't know what it's doing. Why doesn't it work? There's no reason for this not to work. Is Mojang's code just not functional? Is that what's going on here? I don't understand. I'm doing the same thing that everyone else is. Should I change these to catmull rom? That's 1, 2, 3, 4 threes. That's 1, 2, 3, 4, 5 threes. Maybe the duration of the animation needs to be slightly longer. Alright, I'm going to change all these to catmull rom. And then I'm going to change the duration of the animation to 2.03 or something, 0.05. And then I'm also going to look at this. Yeah, it's doing the same stuff with degrees, except it looks normal in the way they did it. Also, okay, so if it's not started, then we want to make sure the head, the X rotation, not the Z rotation, should be equal to 0. So that'll reset the state if the animation's not running. That way the pose won't leak between entities anymore. So that's what I was saying about like conditionally setting stuff. We're beginning to run out of lizards. Okay. Hey man, calm down. Look at that. Perfect. So I guess something about the linear method makes them... Oh, now we're not being normal? That's... Okay. Sure. That makes sense. So it works one time. What? Literally, what is this? Who made this system? What am I doing wrong? What am I doing wrong? I seriously don't know. Because it's not the same entity. They don't all share the same animation state. So why are they acting like it? Am I stupid? Have I made some grave mistake? I'm using the entity's own attack animation state. There's a reset pose method? What? Is that it? Is this why? Okay. So apparently they have added a new system where you can reset the pose. that I had no idea existed, but nonetheless exists. So every single frame we can just reset the pose of everything, and it should make things act more normal. So then I shouldn't even need this. We're gonna see if this works. It looks like it will. So yeah, that was a pose leak that we just saw. The so forsaken event I was just speaking about earlier. Calm down. One at a time. One at a time, guys. Yeah. Look at that guy nod his head. Look at that guy nod his head. They love the cannons. They love the cannons. That's great. Oh, that's awesome. They're so cute. Aww. So yeah, the key was just resetting the pose for every single thing. I guess reset pose must also hook in with the animation system there. That's good to have. Look at them go. And then, so on the client, I'm also going to change the start to start if stopped. So now that everything is working, we can continue. That's very cool. We have a keyframe animation. I've never done that before, so sorry for the technical difficulties, but it's very cool. So now on to our next section, which is going to be spawning. We'll start with spawn eggs. So we can actually create spawn eggs for our entity because right now we've just been using /summon, but having an egg would be very nice. So spawn eggs are just like any other normal item. They have the one difference is they have this model template that they use that's like black and white, and then you apply two colors, which are like the background and the foreground color of the egg, and it like does some special rendering stuff with the item to recolor it. So like in the vanilla like source, it's actually just a grayscale texture that gets colors applied to it. They don't do anything special there. Like they don't have a different egg texture for each egg. It's all one texture. So they usually follow the registry name format of your entity type ID _ spawn _ egg. So if you do something else, people will judge you. And then vanilla has the spawn egg item class, which does all the spawning stuff. And NeoForge has one called deferred spawn egg item that lets you use the deferred holders rather than directly a reference to the entity type, because NeoForge does all its registration like on a different thread, basically. There's no guaranteed order until it actually executes, which means that you can't just give it the entity type because it doesn't exist until it's registered. So you have to give it the holder for the entity type, and then NeoForge will untangle that mess for you. And then NeoForge also has its own APIs for registering the egg color and the dispenser behaviors that the egg uses, because you can spawn stuff with dispensers. So it'll also use those correct APIs rather than the vanilla ones. And then for vanilla, you just use the normal spawn egg items, and that's what Fabric does. You can just use those like vanilla. So to actually make a egg have the correct model, you need to use a normal item model definition, except you just put the parent as item /template spawn egg. That's it. And it'll render correctly. So rather than say item generated like we've done in the past or item handheld, it's just item template spawn egg. And then each spawn egg has its own language entry, which is just the name of your entity spawn egg. You have to actually make a language entry for every single egg. It doesn't just use the one for your entity, which sucks, but oh well. And then you also have to add it to the spawn eggs creative tab manually. It doesn't do that for you, unless you're a cool vanilla spawn egg. So let's go ahead and add a spawn egg real quick. It's really easy. So first thing, we'll go to our items, or mod items. And I'm going to add a little comment for spawn eggs. public static final deferred item, deferred spawn egg item, and then name it lizard spawn egg equals items dot register, not register item. That's for a reason, because register item gives you a deferred it gives you it lets you put a constructor with item properties, but the deferred spawn egg item has special constructors, so we're going to use this one. And we're going to go lizard spawn egg as the mod ID, or as not as the mod ID, the registry ID. And we make a supplier for a new deferred spawn egg item. And the first argument to deferred spawn egg item is a reference to the... Okay, so we need to give it a reference to the actual entity type so it knows how to spawn it. So if we do lizard, and then we're doing a method reference to the get. So basically that's a supplier of entity type. If you look at the signature, we are getting a supplier of entity type. And then it needs a background color and a foreground color. So in Java, you can represent integers as hex, like this, with 0x, right? And that's a valid integer, that's 255. We can basically just use hex color codes as integers. So say I wanted the... We're actually going to pull out a color picker real quick. So if I want a lizard, I'm thinking like green, right? So if I get this like hex right here, and then I put that as the background color, and then we need a foreground color, which I'm thinking will be more like a blackish sort of green. Maybe leaning more towards the yellowish direction. So this will be our hex for the foreground. So now we have the foreground and background colors represented as integers, but hex. So I could just convert this to a number and then put the number there, and it would look very ugly, but... And then it wants an item properties, which we can just do new properties. Don't need anything special there. So now NeoForge will register a lizard spawn egg for us, but it won't have a model. So we go models, item, and create one called lizard spawn egg. .json, like any other. Except this time the parent is going to be Minecraft : item / template spawn egg. As you can see, item template spawn egg. That's it. And then we need to make a language entry, which will be item.catmod.lizard_spawn_egg. And then this is named lizard spawn egg. And while we're here, we should also add a language entry for our lizard itself, because that's good to have. Sorry. So it's entity.catmod.lizard is going to be lizard. That way, if our lizard dies or something and it shows up in chat for some reason, because if you name tag things, they show up in chat when they die sometimes. Like tamed wolves might do that. It won't look stupid. So now our lizard spawn egg has a language entry and a model. We need to put it in the right creative tab. So we can do that the same as anything else. If we're adding to creative mode tabs .spawn eggs, then we give it a new lizard spawn egg. And now that will show up in the creative tab. So let's test it out. Alrighty, open the SpawnX tab. Oh look, there she is. It's beautiful. And if actually, pro tip, if you hit F3 and H, it turns on advanced tooltips, and you can hover over and see the ID of literally anything. So it's cat mod lizard spawn egg. So now, ta-da, we have a spawn egg. We can spawn as many of these as we would like. You can spawn babies too. Those are babies that I'm technically spawning right now. They don't look any different though. I love how their legs move. That's so funny. I really need to turn the speed down though. They're so stupid. You know what we need, guys? Oh, they're so silly. Their tails are so long. Tag yourself. I'm the ones at the bottom. It's poor thing. It's like a free mining drill. They're going mining. Okay. I'm mining with lizards. Eat up. Wow, we've really created the best creature ever created. Something I didn't test last time is you can actually breed them with spider eyes. We never tested that, so I'm gonna breed these lizards. Oh my god, they made a baby! Except they're not any smaller if they're babies. Because you have to add that as a custom rendering thing. So, look at that. Lizards all lizarded up. Sweet. So we can get back to our presentation. Now that we've created a spawn egg. And we get to talk about natural spawning. So actually having these lizards spawn in the world without me using a spawn egg in survival mode. So there's three major types of mob spawning in Minecraft. You have chunk-based spawning, which is what animals use. Proximity-based spawning, which is what monsters and some most sea creatures use. And then you have structure-based spawning, which is triggered by structures. So with chunk-based spawning, when a chunk generates for the first time, it places any creatures. The mob category is very important here. So anything with the mob category of creature, if you remember from last time, mob categories, you assign them when you register the entity type. So it'll try to place any creatures assigned to the biome once when the chunk originally generates, and then very rarely in small amounts every 20 seconds. And so each biome has a unique chance for its chunk to actually trigger a spawning event. So by default, that's 1 in 10, but it can vary by the biome. So in most biomes, 1 in 10 chunks will try spawning animals on them when they generate initially. And then you have proximity-based, which is what monsters, sea creatures, basically anything that isn't a creature uses. So when the player is in a certain proximity of a chunk, which is 128 blocks to its center, those chunks, when they tick, can randomly attempt to place any non-creature entities on them during a spawning tick. And then you have structure-based, so structures can either explicitly place an entity at a location, like an Elder Guardian is placed inside the chambers, inside a Guardian Temple, or it can randomly spawn entities around it, like the way villagers spawn in a village, Iron Golem spawn in a village, normal Guardians spawn around the Guardian Temple, that sort of Vindicators inside of a woodland mansion, that sort of thing. So that link there is actually a really good reference on how spawning works in Minecraft. Do recommend giving it a read. So a little bit more about how mob categories are significant. in terms of spawning. So when you register an entity type, you give them a mob category. It determines how the entity actually spawns when they're in a biome, like I said earlier, with the chunk versus proximity spawning. And then creatures are spawned by chunks during generation, while everything else spawns actively. And then the mob category also determines if an entity is persistent. So basically, does it despawn when you're no longer within 128 blocks of it? So nothing is persistent except the creature and misc mob categories. And misc is very rare, so creature is basically the persistent category. Everything else can despawn when you exit its range. So all the fish, all the zombies, they're just, you leave 120 blocks of their chunk, gone. So now a little bit about the different concepts in spawning. The first is the concept of a mob cap. So the mob cap is the maximum amount of a certain mob category that can exist within a chunk. So not necessarily. It's the point at which the chunk will stop trying to spawn that mob category. So it will only perform spawning until it reaches the mob cap for that category. So anything with the monster creature type or mob category, the monster mob category will have a spawn cap of 70, while most of the creatures have one from 5 to 10. So normal creatures have 10, water creatures and stuff have 5 as their cap. So like a spawning event can cause, like if like 10 things spawn during an event, but the cap is 5, that's fine. It just won't spawn any more after that point. So the other kind of mob cap, there's one more. That's the player mob cap, which is cap mobs around the player, but we're going to ignore that one. Is the global mob cap, which is any non-persistent entity that is currently loaded in the world per chunk increases this cap. And then once it hits that cap, nothing will spawn. So that limits the total amount of entities that can spawn in the world. My voice is done. That limits the total amount of entities that can spawn in the world. Another important concept in spawning is spawn weight. So the spawn weight is essentially, if you know that like multiple types of mobs can be in any biome, they have relative rarities. So each mob type has a weight, which adjusts how rare it is relative to the other mobs that can spawn there. So if the game is trying to spawn entities, it picks from a list, and for every like weight that a mob has, it has like an additional entry into that lottery, essentially. So if you have 2 pig, 1 cow in the list, then it will pick pig 2/3 of the time. And then the pack size. So the game actually spawns entities in packs of like a range. So you can actually specify the minimum and maximum size of a pack for your entity. And then lastly, spawn costs. I'm not going to say all the things that I wrote there because frankly, they're not very useful. The only time they're used is in the Nether, in warped forests and soul sand valleys. Or the soul wastes. That's it. They do weird stuff with spawn distances and rarities. Don't need them. Very optional. Don't use them. So now, how to actually register a spawn into a biome. Because yes, they're added to biomes, not chunks or anything like that. Biomes define which entities can spawn, their weights, their pack size, and any spawn costs. So in NeoForge, they have a feature called biome modifiers, which are data packs, basically. There's a folder in the data folder, and you can specify the modifiers there. So I'll show you that in a minute here, but on Fabric, they have just the code method called biomodifications add spawn. There's not any documentation, but you can look at the code for it and the PR that added it to see how it works. And then one important consideration for when you're adding spawns to biomes is say you added something to every forest manually, like if a mod added a new forest biome, then your entity wouldn't spawn there. So instead, you can target biome tags. So if I use the tag C forest, that's for the common tag forest, then rather than adding it to each forest, it would be in any forest, including modded forests that added their biomes to that tag. So NeoForge, you can directly put tags using the hashtag method. You just put tag biome tag ID, and then that'll be where it gets added. And on Fabric, you can use the biome selectors. One more thing with spawning is there's a thing called spawn placement. So when you're spawning entities, the location that the game like tries to place stuff at can vary between the entity types. So for example, you wouldn't want to try spawning a pig in the middle of the ocean. So the game doesn't try to put it on ocean blocks. It doesn't do that. And land animals can't be placed midair, so it doesn't try to pick air blocks either. So you have the spawn placements registry, and that assigns placement types to entity types, not biomes. So it's associated with the entity itself rather than a biome. And it includes any restrictions on the locations or blocks that are chosen and acceptable for spawn attempts. Notably spawn attempts, not spawn actually occurring. So everything in spawning is an attempt. It tries spawning things, but it has a lot of conditions. So if it fails, it just moves on. So spawn placements are not required, as in the game won't crash if you don't register one. So if I were to add spawns to some biomes and I didn't register a spawn placement, it would just work. The thing is, it wouldn't have any conditions. So my animal might start spawning midair because I didn't put any conditions. So don't forget to register them, or it's going to start being weird. So like, if you try to add something spawning in water and you don't register the water spawn placement, they just won't spawn because they can't, or they would spawn on land or something like that. It would be weird. It'd be really weird. So don't do that. Don't forget. So, when you register a spawn placement, there's a few things you can register with them. The first one is the spawn placement type. So they determine the general type of blocks that are like selected to be candidates for spawning. So you have on ground, which ensures that the block below it is solid. The current block isn't water or any other restricted block like powdered snow, cactus, or fire. Because you don't want to spawn somewhere where you'll just die instantly. And you have in water, which ensures that the selected block is water or waterlogged, and that the block above it isn't entirely solid. So the good thing about this is that waterlogged kelp, that's a totally fine spawn location. Inside the ground, not an okay spawn location. And you have in lava, it's in lava, that's it. And you have no restrictions, which it can spawn anywhere. So you can spawn midair, inside blocks, anywhere. Given the game probably isn't going to pick those spots for you because of this next thing. You have Heightmap types. So Heightmap types determine the location that the game like chooses the candidates from. So the game like normally for spawning stuff on the ground, it goes from the very top block and then finds the first like ground block, as in where the ground is determined to be by the world generator, and then that's where it will try spawning entities. So you can change that behavior here using the Heightmap types. So the most common one is motion blocking no leaves. So this finds the first, like, the highest motion blocking block, as in solid block that you can't just walk through. That is not leaves, because you can't just walk through leaves, but leaves are not the ground, they are usually trees. So you don't want to spawn pigs in trees. That's why it ignores leaves and just goes and finds the first solid block. So usually that's the ground, like grass. And then you have motion blocking, noticeably without the no leaves portion. That's used by two things, ocelots and parrots. They can spawn in trees or on jungle floors on those bushes. So, good to have that. And then lastly, you have, and a little bit, these last two here, those aren't used by entities, so you don't have to worry about them. And just note that you probably shouldn't use those. That's why they're there. This last one is the spawn conditions. So alongside the placement type and the Heightmap type, you can actually put custom conditions on whether something can spawn. And this is the important part. This is what you should register. This is why I'm saying don't forget to register, because this implements behavior like how monsters can't spawn in the light. It's a spawn condition. Or like how animals can't spawn on slabs. It's a spawn condition. So it's very important like that you don't forget these. So all it is a method that returns if the position is acceptable for an entity to spawn or not. That's it. So you'd use lambdas or method references there. So it enforces any additional restrictions. So there's a few common ones that are used by a lot of entities. They're generic ones. So your entity might have more specific logic, but you should also make sure to have whatever these have for your entity in a way that makes sense. So the animal one basically just checks the animal spawn safe tag, and then also make sure that it's not like a slab or something like that, and that it's on the ground. The water animal one, making sure you're in water, but it also enforces a requirement that you're not below the sea level, or that you're below the sea level, but you're not like underground. The monster one, there's one for light, any light, and there's one for darkness specifically. And that also enforces if you're on peaceful, they won't spawn because of that. And then you have mob, and that one is used by just anything in general. Most things are using some form of mob check spawn mob rules at some point. So those are the common ones that you can use. And in terms of how to actually register them, they are global to an entity type and don't vary by biome. So those are the two ways you can do it on NeoForge. It is register spawn placements event. It's an event you can subscribe to, and on Fabric you just use the vanilla method, which is spawn placements.register. And then the default like spawning placement, so if you were to just register it without the placement type or Heightmap type, because on NeoForge you can do that, you can just put a condition. They're called spawn predicates. The default is on ground with motion blocking, no leaves. But you may want to change that. So you can register it using that method, the two methods. So now I'm going to demonstrate adding a natural spawn to our entity. So I think the lizard should spawn in the desert, because that's where lizards live, obviously. And that's it. I'm just going to put them in the desert. So if we go look at the registering spawns page that I made here, I have a link to the NeoForge docs on biome modifiers. So it says they're a data-driven system that allow for changing aspects of a biome, and there's several default ones. So what we're looking for is add spawns. Here it is telling us not to forget our spawn placements. Because your entity could spawn midair, fall, and die. Yes, very important. But, so it's just saying this is what a spawn looks like. So I'm going to copy this. And then it also says that these go data mod ID NeoForge biome modifier. So I'm going to do is this the right one? Yes. So it goes in resources, data, cat mod, and then I need to make a folder called NeoForge, and then a folder called, what was it? Biome modifier. And then inside of that, we will create path.json. So it looks like I can just pick a name for it, which I'm going to say. I'm going to name it lizard spawns.json. Then that's JSON. We're not doing that. Okay. So if we just delete these comments, because I will explain them all, and they're breaking things. So we have the type, which is add spawns, the biomes we want to add it to. So I'm going to do C desert. So any deserts. Let me make sure that that tag exists. So if we go to the NeoForge source, right? And then we go look at resources, data, C tags, and then world gen, biome, and then we're looking for desert. It's called is desert. So we're looking for C is desert, not desert. So is desert. And then we want to spawn a cat mod lizard. And then so the weights, it's kind of important to like understand what weights look like for other mobs. So with monsters, they usually have much higher weights, like 100. It's very typical. With animals, they usually have much lighter weights that are more like 5, right? So if you actually go look at the spawning page on the Minecraft wiki, you can see what vanilla weights look like. So the sheep has a weight of 6, cow has a weight of 4, but you'll see what I'm talking about with monsters. They have weights like 100. So you just sort of make your weights relative to what vanilla is doing. So my lizard, I think it's going to have a weight of 4 because they're about as common as a cow, I would say. Now it depends because like a desert might spawn different things than what a forest is spawning or plains. So what's in that list can vary a lot, and so the weights can mean different things depending on the biome you add them to. But I'm going to choose that weight. And then I think lizards should spawn in groups of 1 to 6 because they're tiny and they spawn in big groups. So that theoretically is what we need to add a spawn to the deserts. So now we have to make sure not to forget to register our spawn placements. So we need the register spawn placements event. And I think I'm also just going to put that in here with the entities. We just need to make sure that this is on the right bus. It fires on the mod bus. Yes, iMod bus event. So we are on the correct thing here because you'll notice here we're subscribed to the mod bus. So now we can do .register mod entities.lizard. And then we can register the entity type. And then we can do spawn placement type on ground. And Heightmap.types.motion blocking no leaves. And then we need to give it a condition for spawning. So we're just going to use the default animal rule. So the animal rule checks if it's bright enough to spawn, which we actually ignore brightness, so it doesn't matter, and then checks if it can spawn according to the block tags, and that's it. I think. Oh yeah, it actually does check for a certain brightness. So that's why animals don't spawn in caves. As well as because of height maps, but If it was dark, then they don't spawn. I'm not sure why that's not working there. It doesn't consider this a valid spawn predicate. I need an operation. What is an operation? Okay, so if they're conflicting, as in something else registered as spawn placement, it tells it how to interact. So this is our entity, so I think we can just do replace because it's ours. But also that's probably bad for compatibility reasons, so I'm just going to put and, I think. Is that the default? The default is or. Okay. We'll just do that then. I don't know. So now we've registered our spawn placements. That's a NeoForge thing, this operation here, so that's why it's not on the slides, because it doesn't really matter in the grand scheme of things. But now we have spawn placements and a natural spawn in deserts, so let's try it out. One important thing to note is that this spawn won't exist for any chunks that were already generated. So if I were to open my world that already existed, and I walked into a desert that I've already loaded before, there won't be any lizards there, because spawning doesn't take place very often during runtime. It only really occurs during world generation. It's very rare outside of that. So if I were to go to a desert that I had loaded, it would not spawn lizards. But we can go to a desert that I have not been to before on a world that already exists. Which I probably haven't been to a desert yet on here because I haven't really walked very far. So now I'm going to do locate biome, desert. And is that location. So we'll just teleport there. Okay, so because that didn't work, I'm just going to create a new world.
You could do a single biome one.
Yes, that's what I was going to do. So now I'm going to create a desert world. And we'll search for our lizards. So here's one thing I like to do when testing spawning. When I can't find stuff by hand, if I do TP self to the nearest type cat mod lizard limit equals 1, it didn't find any. So that's searching for any entities that are lizards and finding one, teleporting me to it. But it didn't find any. So we shall continue. I think if we look at the desert, if we go to biomes and then find desert, biomes are data driven now, so they actually don't exist in the code. That's not true. I want to find the frequency of rabbit, but we can also just look on the wiki. It's 4, so we should be spawning approximately half the time because we are also 4. But I'm only seeing rabbits, so that means something is wrong. So, okay, here's my theory. the spawn placement conditions aren't working correctly, and so they're just like not being allowed to place. And so we should see even less rabbits this time, because every time it fails to place, just nothing gets put there. So instead of seeing lizards, we're seeing nothings spawn, and then rabbits are the only thing that you can see because they're passing their spawning conditions. So my theory is, if I close the game, go remove the spawn condition right here, and then start it back up, we should start seeing lizards.
I see lizards.
Holy... Yeah, but since we removed their spawning conditions, they're spawning in water, which is not what they're supposed to do. So that's... See now why we register our spawn placement conditions? Very important. Otherwise, the lizards will spawn in water. Where is the actual desert? There you are. So now we should start seeing lizards on the land. Yes, yes, there they are. The problem is, they don't seem to want to spawn with conditions for some reason. So what this does tell us is that our conditions at least are registering, but they're not working how they should. So oh, wait a second. I just got another idea. This tag, animals spawnable on, maybe that doesn't contain sand as a valid block. And then rabbits spawnable on does, right? Maybe that's what's going on. That is my idea. What? Me, 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 me. Shut up. Okay, I guess you do need the types. So, okay, I think that makes my theory true. So I think that sand is not an acceptable animal spawn block, and it is for rabbits. So you know what? Screw it. We're just gonna steal the rabbit one. Except it's not written for me, so I'm just gonna do it like this. Okay, I think that'll do it, because the rabbit spawn blocks will have sand in there. And it's going to check the light level to make sure it's sufficient. Which we should see way too many lizards, because I upped their weight like super high. Yep. There's the lizards. Naturally spawning in the desert, and if we walk over to the water over here, they're not in the water. They are only on the land, because the water is not a valid spawn block for lizards. Ta-da! Look at them go. You know what you need, Mr. Lizard? You're hungry. I know you are. I know you're all hungry. He's getting full, guys. Oh god, I love these things. They're so stupid. Oh my god, he's swimming. Eat up. So, yeah, that's natural spawning. Hooray! Lizards everywhere. Alrighty. So now I will continue my presentation. These are the last few slides. So navigators and movement helpers. These are something I wanted to get to last week with the AI section, but I didn't manage to get through. So a navigator is basically the pathfinder for an entity. So every pathfinding entity has a path navigator. They're called path navigation technically in the game. That's the name of the class, but it's an implementation of a protocol that allows entities to find valid movement routes between two blocks, 2 points in the world. So it's how entities move around obstacles, jump up blocks. So instead of just walking in a straight line between 2 points, they can actually intelligently move around things. If you put a wall in front of a zombie, it's still going to follow you around the wall. So different navigators allow different paths to be different navigators allow like different paths to be determined. So a water navigator operates on the assumption that you can swim freely up and down through water, nothing in your way, but it also doesn't allow you to walk on land. But a ground navigator would avoid water because it's slow to go through. But if absolutely necessary, it assumes that you can swim through water. So there's a few existing path navigators that other ones can extend from, but the one is water-bound path navigation, so that's you're stuck in the water. Ground path navigation, which is basically everything that walks on the ground. Flying path navigation, which is used by bees, parrots, alleys, and withers. Notably, not ghasts, bats, or phantoms, because they don't pathfind at all. I mentioned this last week, but they just fly in a direction because they don't really collide with stuff. Especially phantoms, they just go through stuff. And then you have amphibious path navigation, which is used by turtles and frogs, which lets you go through both water and land efficiently. So to use a navigator or change the type of navigator from ground, which is usually what you're doing, you can override create navigation and then just return a new instance of the navigator. That's it. And you can also make custom ones, but that involves a lot of pathfinding algorithms. So if you want to figure that out, go for it. But I'm not going to go into that. And then you have movement helpers. So movement helpers are what determine how an entity actually moves between the points that the path navigator provides. So path navigator is smart and gives you different points to move to, but the move helper is what actually determines how the entity approaches that movement. So for example, a ghast just flies directly vertically between the 2 points it has been assigned to fly to. It doesn't pathfind, but it's a good example of movement helpers. It has a custom one for itself that is literally just move in a straight line through the air, ignore gravity. But most entities use the ground move helper, which takes gravity into account and like jumps up ledges and stuff, right? So that's a movement helper. So to use movement helpers, during your entity's constructor, you just assign the move helper to this .move control. And that is it. You just make a new instance of the move helper, assign it. The default one is usually fine, but if you wanted to adjust your move helper, for example, like for a flying mob, it would be very helpful. And there's also a look control and a jump control, similar to move control, that do what they say. So if you want to take a look at those, feel free, but we don't need them. Have fun modding. All done. Thank you. Thank you.